All right. Hello, everyone, and thank you for joining us for this webinar on prompt engineering. I'm Gadi. I'm a solution architect here at Aporia. And just to make sure first, we're going to have this chat going through the webinar. Yeah, okay, I can see you. Shy root test. Great. Okay, so I'll start by introducing myself. A short introduction about some of my hobbies. I really like hiking around the world. And I also really love music. I play the piano, the guitar, I dance Brazilian zouk, and I listen to a really wide variety of genres. And you can find me on LinkedIn, and we can stay in touch right after this webinar. All right, let's go. So a few a few goals first for this webinar, because we have so many different people here from many different backgrounds, from the engineer level to the management level, then I want everyone to get something out of this presentation. So we're gonna talk about some introduction to prompt engineering, and I'm also gonna make sure to provide you with some practical tools and mostly references for you to read on later and to get to know more about the topic. And lastly, it's really important to me for this to be interesting for you guys. So if you have any additional questions during this webinar, please feel free to use the chat. Also, feel free to send some random messages during it. I'll try answering your questions. And the way I'm going to do that is at certain points, I'm going to try and stop and see if it's a good time to answer you guys' questions. I can't promise I'll answer all of them. And I'm also going to try to keep some time at the end to answer any leftover questions. All right, so the agenda for today. First, we're going to start with the intro to prompt engineering. What is it and why? We're going to talk about something to call the manager approach, some techniques and strategies for prompt engineering, famous ones as well. And from there, we're going to continue and try to understand that there is more to prompt engineering, and not only the techniques and strategies, and we need to look at it from different perspective as well. And at the end, we're going to talk about some of the limitations of prompt engineering, prompt overloading especially. All right, so I'm going to start now with an example from a user's perspective, because in the end, this is all about the user. So this is something that happened to me a couple of months ago with an airline company. For just to keep the reputation of the company, I'm going to call it difficult airplanes. And so what happened is something along the lines of what happened here. I had a canceled flight and I needed a refund. So started using the chat, and like every good chatbot, it starts with asking for information. So I provided my name, the booking reference, and the complaint. So it starts answering, and it's all very nice. It knows my name. It understands what I'm here for. But then, yeah, this happens, and I think you can understand the frustration that's starting to accumulate at this point. The conversation ends up looking more like this. There's the live representative part. Of course, I say yes. It can't really understand what I'm asking for, so I don't really know what to do anymore. Okay, so I think it's really important to understand that at the end, all of our applications have end users. Even if they're like an AI labeling at the background, at the end, it's going to affect the user one way or the other. And this is very important for us. And we really need to care about it. And this is why prompt engineering even started. So let's look at the developer's perspective and this example. most AI platforms nowadays allow you to define what we call system prompt. And if you try and define something like very simple, like assist with customer inquiries, then you're gonna get these very simple responses. So instead, we try to enrich each prompt, the system prompt as well as the user prompts, and give additional instructions. Like for this case, the role, you're an airline company, customer service, provide detailed responses. We're telling them how to answer, and we're telling them what to use available data such as the booking references. And that way we get much better answers that are much richer, and they're what our users are looking for. Okay. So prompt engineering is basically trying to find the best prompt and fine-tune it in a way that gives us the best result. So we expect the AI to do a lot with these prompts. We expect them to summarize articles, to write code, and we expect them to make this webinar happen. I like using AI. So when we do all of those things, there's a lot of frustration. We try to, we require a lot, we ask for a lot, and it gives bad responses all the time. But I want you to think for a second about something similar. We have this amazing, robust product called Google, okay? Whenever we ask something from Google and it gets it wrong, there's this subconscious moment where we simply retype. We don't even think about it. We don't, it's so second nature nowadays that we just go ahead and do it. And if this problem still arises with such a robust product, with a very definite task, then of course it's going to happen with the AI we're using nowadays. So thinking about this example, if with such a simple product these problems happen, then of course it's going to happen with AI as well. Not only that, it doesn't only happen with Google, it also happens with people. All right? When we ask for someone to make us coffee, we ask a colleague to make us coffee. If we don't tell them how we want it, they're just gonna go and make some coffee, and we're gonna get it with milk or God forbid some sugar. And we should make sure to ask for what we want very carefully. So this is why I like to call this the manager approach, because AI is like an employee to us. We use it, we task it with a lot of different things, and then we expect it to give us the results. But we need to make sure that we give it the clear instructions. We need to make sure that we ask exactly for what, like for the specific things. We need to be very precise. We need to break tasks that we give them into smaller tasks. And actually, we have here OpenAI's website, and in it, I'm just gonna quickly jump into it. In it, we have a few strategies that OpenAI themselves give us, the makers of AI applications. And these strategies really do sound like a manager with their employees. Provide clear instructions, okay? Give examples and give information for our AI to do their job. Split that complex task into smaller subtasks and give the model time to think. Again, this is all so similar to asking for help or taking or leveraging our employees. So I'm gonna jump now into the actual practical techniques. If there are any questions before I go, I think it's a good time for you to ask. If not, I'll just keep on running. All right. So moving on, the techniques. There are so many techniques out there. We've got few-shot prompting, chain of thought, self-consistency, and so much others. I'm not going to dive into all of them. I'm going to talk about a few examples on the way. I do provide during this webinar a lot of references, a lot of links. And when you get the recording, you can also go and search and read about these. I really encourage you all to. So I'm almost sure that some of you will know like almost all of the techniques I'm going to talk about today. But even still, how many of you have really tried leveraging these techniques like manually, finding a specific use case where there's a problem and trying one or two different techniques to see how they help you resolve the problem? I know from experience, a lot of times I haven't. Like mostly when it comes to techniques, I've read about them, but then we also have a lot of infrastructure that makes it easy for us to use without really understand what we're doing. So I'm gonna get more technical now, and we're gonna go through 3 examples of problems that arise when using AI and different techniques and how they really work and what the concept is and when is the right time to use them. Okay, so having this notebook here, these examples I'm going to share with you, they're based on examples from promptingguide.ai. Again, another great website. I really recommend checking it out. It has some great introduction into different topics and like the different leads to continue on your journey learning about prompt engineering. I took some of those examples and just blew life into them again. And using GPT-4, I made sure that that we get something valuable out of them. So let's start with a simple, with these 3 ones. These are simple, the more simple kinds of techniques, but they are in use in a lot of different places without even realizing it. So the first one we call few-shot prompting. Okay, the idea is that sometimes we try to give instructions to our LLM, and you're going to see that a lot when you try and fine-tune your prompts. You're going to be giving more and different instructions. You're going to be trying to rephrase them just in tiny different ways to make sure that to get a bit tiny bit better results. But for some reason, it doesn't really understand what you want it to do. So that's why, in addition to providing instructions, or sometimes even without providing the instructions, you can just give a set of examples of the task at hand, and then the AI can see these examples and learn what needs to be done. In this use case, it's pretty obvious that we're trying to label the sentiment of a sentence. And giving it an instruction to do that, a very specific one, is very difficult to do. And still, when we activate it and run it, we get a great result. So this technique, while on its own is not very useful, you're going to see it in the backend working underlying with other different techniques, leveraging it. Moving on, we have chain of thought. This case scenario happens when we have a complex problem that requires reasoning, like very complex reasoning. For example, a math problem, something that AI are notoriously bad at. If we ask an AI to do this question, we're just not going to get the result we want. Instead, what we could do is add to the prompt a short guide telling it to do some thought process first, to break the problem into smaller tasks, and try and using that chain of thought to resolve the problem. Now, I'm not going to run this one because it takes a while due to the amount of output tokens, but as you can see here, it amazingly creates the correct steps for long multiplication and eventually adds the numbers to the correct result. So a very, very simple and small change to the prompt causes it from being, well, a mistake to 100% accurate. Chain of thought is sometimes also used with few-shot prompting and other different techniques combined. to produce some great results. Again, chain of thought is great for cases when you need to use complex reasoning. It might not always be the best way to go. Sometimes you're going to need some very real-time responses, and you just can't allow yourself the time to generate a bunch of different tokens that are not going to be used eventually. So it really depends on your use case. But we see more and more infrastructure using chain of thought one way or the other. A third example we have here, something called knowledge generation. So imagine we have a quest, like a fact or something that we need to check. Just a sentence. In this case, the human body has 273 bones at birth. Yes or no? So I'm going to tell you in advance that there's no really definite answer to this one. It's not just a yes or no response. There are about 270 bones, but it's the basic answer is no. Okay? It's not true that we have this amount of bones at birth, and yet the AI responds yes. So knowledge generation, what it does is you manually break up the task into two different parts. The first part, you generate knowledge about the question, about the task that you're going to have to solve. And the way it's done in this example is using few-shot prompting. We have different types of inputs that we could ask yes or no questions about. And for each input, we give an example for knowledge that is relevant to that input. So once we run this, we force our AI to first generate information regarding the input. So in this case, the human body has approximately 270 bones, this total decreases, etc. And we're going to put it in a variable and then pass it again using a second prompt that asks the question. We're going to ask the question at hand. We're going to give the AI the knowledge and task it with answering. And no. Okay. So this is a great example of leveraging prompt engineering techniques for problems that could arise. Again, I really encourage you to read about all of these different ones, and even try them. Play around with them. It's really important to understand their limitations, and understanding those limitations is extremely important once you try incorporating some more complex techniques. Let's talk about some of these more complex techniques. So instead of only having the language model do stuff and try and change the prompt a little bit one way or the other, telling it to do things step by step or break into like smaller actions, we can also use tools, right? We can use external tools. The most famous architecture here, RAG, Retrieval Augmented Generation, is where you get the user question, and instead of just sending it as a prompt to the language model, you first retrieve relevant information, add it to enrich the prompt, much like knowledge generation, which I just showed. But instead of generating the knowledge with a language model, you have a source of truth. You have actual data that you know is right. And so you minimize hallucinations to a certain degree. So you enrich the prompt, send it to the language model, and get an answer. This is the classic example of using tools. We also have auto reasoning tool usage, ART, and React, which is short for reasoning action. React is a dynamic way of incorporating chain of thought, asking the language model to break the task into smaller steps. At each step, it's going to find what is the tool it needs to use. It's going to use it and then continue on to the next steps. So again, I think this is a good example demonstrating how learning about the more simpler techniques and mastering them helps us understand the more complex ones and also their limitations. Okay. Any questions? Let's see for now. Nothing yet, right? So we have all these techniques, and how do we choose? Different techniques have different benefits, but at the end of the day, this all requires trial and error. Oh, I think, I'm sorry, guys. I think I'm looking at the wrong chat here. So I'm going to take a moment just to see if I can see one. Okay, I'm going to ask for someone to figure this out. Okay, so okay, guys helping me here, my co-hosts, if you would please send me the questions here on a different chat, that could help, as I can't see the questions being asked. All right, so you guys, there's gonna be some extra delay when you ask questions, and they're gonna go through my colleagues here helping us. Okay, so back to the topic, we have a bunch of different techniques. And oh, okay, I see a question here, like, doesn't RAG improve the accuracy of the prompt? Yes, RAG does improve the accuracy of the prompt. And that's actually a very good example of how prompt engineering is useful. We're also going to talk about some pitfalls regarding that up ahead. So like keep the RAG topic in mind. All right, I have another question here. In production, when creating these engineering prompts, do you usually do the training in Jupyter Notebook, or how is the structure usually? Okay, so I'm gonna talk about the training later on. I really recommend Jupyter Notebooks for these trial and error, what we're talking about here. But for most people, and for myself as well, these trial and error using Jupyter Notebooks is not a sufficient answer, because we're gonna do that, and we gotta ask ourselves, like, when should we stop? Like, when did we get a good result? And how do we know we've reached a good structure for our problems? Did we get a good solution? And that's the entire problem about the approach, the view I'm talking about here, about the trial and error point of view. We don't know if we're erroring or not. So this will require a different point of view. Language models are not people, okay? Instead, we've got to view them again as what they are. They are very complex prediction models. And what it means is that prompt engineering is optimizing a parameter passed as part of this entire system, and we're trying to optimize it for the best fitting prediction. Again, these are prediction models. But what does best fitting even mean? We need to define what it is, right? We need to define what is the best fitting result for us. We need to define some kind of metric, some kind of way to evaluate ourselves. Ergo, the scientist approach. So evaluation is key. And here I'm going back to the question, for when creating these engineering prompts, it all must boil down to evaluation. If you don't have a way to evaluate yourself, then you're going to try a lot of different techniques, but eventually you won't get, when you go to production, you're going to see a lot of different problems. So ways for evaluating, first of all, active labeling. That's like the holy grail of what we wish we could do. Manually labeling the results. We have a set of tasks that we define, and we use a prompt, we run it on all of them, and then go ahead and label the results we get. Manual labeling and doing that with a bunch of different prompts is infeasible. it doesn't hold up in scale. This approach is good for trying some very general new ideas, but you're not going to do this very often, if at all. It is pretty accurate. Again, it's like the holy grail of what you would want to have, but yeah, probably not going to happen a lot. Instead, what we're seeing nowadays more and more, you know how we're seeing like more data sets appearing, like these new like hallucination evaluation benchmark, and these new set of 100,000 questions, and we have here Google's natural questions data set. So if we look at these data sets, what they contain is a bunch of tasks and desired results. And we're told to use these data sets to try our prompts or train our models, etc. But how can we do that properly? And the way it's done nowadays is by a method of synthetic labeling. We first use the different prompts we want to test, the different models or architectures, and run them on the tasks. We get the list of results, correct answers, and we compare them to the desired results. How do we do that comparison at scale? Well, using a language model. So that's why it's called synthetic labeling, and that's why it's a little bit less accurate than actual manually labeling, but it is still great. And the reason it works, while the leading conjecture for why it works pretty well, is that the action of comparing one answer to another one and producing a binary result is a much simpler task. Than, oh, sorry, I have a question here that's kind of important. If you're asking if by tasks I mean prompts. Okay, so let me make it clear. By task, I mean the analog to a question. If we have a chatbot, then the task is a question, but sometimes it's not a question. Sometimes it's summarize this article, summarize a Wikipedia article. So we have a list of tasks. If I go back to the airline chatbot example, then it could be a bunch of different questions that could appear. Questions about flights, about airlines, about prices, anything you could imagine. These are what I consider tasks. And whenever we want to check one of our prompts, we're going to run that single prompt on each of the tasks. Okay, on each of the questions, we're gonna input the question into our prompt template. And very similar to what I showed with the knowledge generation. And then we're gonna run it on the entire data set and get some numbers like recall or precision, accuracy. Does that answer the question? I'm sorry I stopped here. It's just really important to get this part straight. So once we run our language models on the tasks using a prompt, like one single prompt template, and we get all of these different results, then we can compare the results to the desired results, get the labels. And the reason, what I was saying is that the reason this is considered plausible is because the task of producing a good result is way more difficult than checking if a result is similar to something else. Moving on to the third evaluation method is another great one, which actually I don't see very often people talking about it, but I know for a fact some companies some very big companies are doing this. A/B testing using application metrics. So if you have your own KPIs defined, for example, in the airline company chat support, a good KPI could be the amount of times like a customer put a good review, a 5-star, or the average, like the average review. So if we have these metrics that we know for a fact are what we're looking for, then we can use them and test them over time, each time with a different prompt. So just to emphasize what I mean, let's say you have a chain of thought prompt you want to try. So instead of going about and trying some synthetic labeling and everything, you just throw that into production and you take a certain period of time and see if in that period of time the KPIs went up, down, or whatever you were looking for. The pros of this method is it's directly what you're looking for. Instead of trying to improve what we call the accuracy of the models, we're trying to improve our application, the end product. The con is that not everyone can allow themselves to do that. It's a high risk. We basically say, hey, we have this product and we're testing it on you, and let's hope it doesn't ruin the user experience. So with these evaluations in mind, also come newer techniques for prompt engineering, right? So the evaluation is not only to make sure you're on the right track when trying and testing your new prompt. There can also be used as part of a larger mechanism to create these very good prompt templates for your use cases. Instead of going and trying to slowly iterate over a prompt, you can create an infrastructure that already takes a prompt, like a prompt template, and iterates on it, tries different variations, and compares those variations to the metrics you're talking about. Here I have an example of automatic prompt engineering taken from the article. So we have here a language model that tries to propose a result, to answer a question. Then we use another language model to score that result. So the scoring here appears as a fractional number. We can actually go back and take these data sets we're talking about and use them. And if it's like a similar question to something that was already labeled, then we can use that and try to improve the labeling. And using this and iterating this on various different prompt templates, we get to a point where slowly over time, we get improved results. There is an additional optional step here using resampling just to keep this scoring model in check. Like always, I encourage you to go and read. DSPY, an amazing framework for improving your entire architecture. It's much more than prompt engineering, but they also provide, as part of that architecture, ways to automatically find the best prompts for the task you need to solve. And the way they do that is by letting you actually use some of the metrics that you want to define on your own. And so this is why I really like DSPY. And now I'm going to take some time to read some of your questions. So I think it's a great time to also add if you have anything else. Okay, so I have a question here. In general, is there no industry standard for creation? I'm curious in logic, what would the downside be beside resource or time? Um, just to make sure for creation, are we talking about creating the prompt templates? So I'm going to continue reading. If we use an AutoCares or auto model that will autonomously find the best model after testing all the different models or hyperparameters, or is that just not an industry standardization? So, okay, there at the moment, there is no like industry standard for creating the best prompt. I've seen lots of different point of views about this. There are also like some very esteemed engineers saying that, okay, we already got the basic techniques and like they're good enough. We're not going to get any further. Let's continue with what we have, unless we have like some really novel template or concept that we think about. It's also a valid approach. Again, with these new automatic techniques, I think it's getting more interesting. Another question here. In the automatic techniques, what does the model evaluate? Is it the prompts themselves? Okay, so in these automatic techniques, we have a model evaluating our responses, and we again we do that using one single prompt template, and this helper scoring model scores or labels the results, and we use all of these data together to get an evaluation of a prompt. Okay, so again, we have a single prompt template. We run it on a bunch of different questions. We get a bunch of different answers. And then we see if it succeeded with an overall good score or an overall bad score. We have usually another model that tries different, tiny different variations of the prompt template. And then each time, again, we run it against everything and try to get results. All right. So that way you slowly advance to a prompt template, to a prompt that is fitting your specific application. Hope that helps. Okay, so moving on, let's talk about some of the limitations of prompt engineering. Just to clarify, okay, another question that arises here. I'm talking about prompt engineering from the AI developer perspective. Yes, when I'm talking about these prompts, usually what I'm referring to is the prompt template, or the prompt template using with the question already in it. No, I'm not talking about the AI chat end user perspective. All of these evaluation metrics are for us developers to make our chat applications better. Okay, the limitations of prompt engineering. So back to the airline example, we have our users and the system prompt. Suddenly we have some nasty users starting talking about sports with our AI chatbot. And we don't want that to happen. It takes a lot of token usage, and we're not here to give our tokens for for free. And so we try adding an instruction, something more clear. Only talk about the airline and flights. But then after a while, we see some like other different behaviors, someone talking about the weather. For some reason, the previous instruction did not work, so now we need to add something more specific, like don't talk about the weather. And this can go on and on, not only with off-topic conversations, but also with like sudden hallucinations of our model, or sudden toxic language that can appear, aggression. And if we keep on adding more and more instructions, what's going to happen eventually? We have this giant prompt with a bunch of different instructions telling our AI exactly what they need to do. Back to the manager approach I was talking about before, if we tell our AI to do to do a lot of different things, don't do that, don't do that, don't do that, don't do that, it's gonna lose track. That's what we call prompt overloading. There's a really nice, pretty recent article from around February this year, where they show how increasing the input length of the prompt, basically adding more and more instructions, causes the general accuracy of what we want to solve to drop. And it makes sense. I mean, we have a bunch of different things we want the AI to do. And when we overload it with the instructions, it fails to keep up. So what can we do about it? I'm going to go back to the RAG architecture now, and I'm going to use it to demonstrate the concept. Again, this is not only relevant to the RAG architecture. This can be relevant to almost any different architecture. In the RAG architecture we saw before, we have the user question, the data retrieval, which come together into the prompt, again, using a certain prompt template. And we've been talking about prompt engineering, improving this part. Okay, this part where the user question also comes into play. But we can look at other parts of the system. We can improve the retrieval, okay, for RAG specifically, but for other use cases, it could be other different tools that are used here. And it could be like natural language to SQL. Anyways, improving the different tools we are using that are helping us to get better results is a very critical part of getting the best result. Also, fine-tuning. Fine-tuning models, if you have the methods to, is life-changing. We base a lot of our success on fine-tuning. It's just like when you have a very clear task that needs to be done, fine-tuning is the way to go. But again, sometimes you meet edge cases like prompt engineering, and you're not going to be able to fine-tune on all of these edge cases. And that's why we also recommend incorporating a guardrail system. A guardrail system, it basically sits in between the app, all of the different parts of the app together, and the language model. When you insert a prompt, it passes through the guardrails and gets to the LLM answers. And so the guardrail system can look at the prompt and response and use them to mitigate a lot of the different problems we were talking about before. Like, for example, we want to prevent a lot of off-topic conversations. Okay, I'm not gonna delve too much into it now, but taking a look at the different approaches is very important. All right. So quick summary. Oh, okay. I have a question here. can talk more about guardrails. Yeah, I can add a little bit more to the explanation. The point of guardrails is that you have all of these edge cases and you have all of these different problems that could arise, and you pretty much maximize on your prompts, you pretty much maximize on fine-tuning, or don't have a way to continue fine-tuning. And you want to have something something that helps you mitigate these issues. Guardrails can even be used to catch hallucinations. It's like a middle layer that that sits there and like helps prevent and mitigate a lot of different issues that appear. I encourage you to go to our website, Aporia, aporia.com, read more about guardrails. If it's of interest and like sounds relevant, you can also like schedule a demo or something, maybe. And like feel free to reach out on LinkedIn. I'll be answering questions after this webinar as well. You can add me and we'll stay in touch. So back to the summary, unless there are more questions here, my fellow is passing me. All right, great. Oh, yeah, we do have a question. If I can provide resources for Aporia guardrails, yeah, of course. Do that real quick. Go to gr-docs.aporia.com. Get started. You can read everything you want here. We will be sending a summary email with everything as well. And you'll also be able to see the different articles I was mentioning during this presentation. Right. So prompt engineering, we saw why it's important. We saw there are plenty of techniques out there, and they're just waiting for us to grab them, learn about them, and find the best ones for our use cases. We saw that simply talking about prompt engineering and reading about like a lot of different techniques is not enough. To get real value out of this, we have to have evaluation. It's critical, and it is also possible. Even without like manual labeling, it's possible. You can do it, and you can get great results. We also saw that there are limitations to prompt engineering, to how much you can fine-tune and improve your prompts. And you gotta overcome these limitations using other methods. If you have any more questions, have a system prompt for your questions also. Feel free. I'm gonna wait a few seconds, and if nothing else rises, then. All right. Thank you all so very much. Thank you for your time. It's been a pleasure. And again, feel free to contact me. You have my name. Find me on LinkedIn. And any more questions, you can ask me there. Awesome. Thank you very much.